Hello and welcome to another exam paper walkthrough. Today I'm going to be continuing with GCSE maths, and this is a slightly different AQA paper. This is a pushing for 9 paper. So what I've done is I've gone and looked and using AQA's advanced exam analysis QLA document, I've gone and looked at all of their most difficult paper 1 questions, and I've selected around 90. I think it's 89 questions and arrange them in order of difficulty. So this is really for those of you really pushing for the top grade on a higher paper. Attached to the description to this video, you'll be able to download a copy of the paper. I would strongly recommend you've either done it beforehand or do it alongside the video just to get the most out of it and really focus your revision. Like I say, this is in preparation for the June 25 series, and this is obviously the higher paper, although this would be excellent revision for any exam board. Anybody really pushing for a grade 8 or a grade 9, I think would benefit from this paper. If you find this video useful, please do subscribe if you like, and you'll get any other videos as soon as they're released straight to you. I'll do the grade boundaries and the question analysis at the end of this video, and we will just crack straight on with the questions. Okay, so here's a copy of the paper. I didn't mention in the intro, please feel free to have some music on in the background. I've got some on while recording, just to make this a bit more enjoyable. Okay, so question 1. The Venn diagram represents 100 items, so that means that all of these 4 numbers should add up to 100. Write down the probability that A and B, that means the intersection, so that means anything in A and in B. So we've got 13 in the intersection, so that's 13 out of the total number. So that would be, let's check, let's start in blue. That would be 13 out of the total number, which is 100, so 13 out of 100. That one won't simplify, so 13 out of 100. You could do it as a decimal, 0.13, or as a percentage, 13%. All of those would be fine. Part B, work at the probability of A dashed. So that means the complement of A. So that means the probability of it not being in A. So the probability of it not being in A is it's got to be in that one or that one. So we're looking at 48 plus 11 out of 100. So that's going to be 59 out of 100. And again, that 59% or 0.59 would also be absolutely fine. And then part C, work out PAUB. That means the union of A and B. So that would be these 3 added together. I'm going to do it slightly different. I'm going to say it's going to be the same as 1 minus the probability of it not being in either, which would be 11 out of 100, which would give me 89 out of 100. That's just slightly shorter. Those 3 numbers would add up to 89 as well. Question 2, here is a number machine. So we've got x, we've got times by a, we've got plus b, and we've got y as our output. Show that when the input increases by 2, the output increases by 2a. So to do this, we could put any number in that we wanted and show that the output was 2 more. I'm going to do it using algebra though. So I'm going to say if we put x in, what we would get out would be so if we put x into the input, our output would be ax plus b. And then if we put something in that's too bigger than x, so x plus 2, our output would be, and I'll do this unsimplified first of all, x plus 2 plus b, which would give us ax plus 2a plus b. And then I'm going to just rearrange it like this, 2x plus b plus 2. Then I'm going to underline this part here and say this, just indicate that this would be same output as x input. And I've missed my A there. So 2A bigger. And again, you could have done this with a number. So if, for example, I put, doesn't really change. If I put 1 in, my output would be A plus B. And then if I put 3 in, my output would be 3A plus B. So I could argue then that that's the same as A plus B plus 2A. So I could have done it with a number, but doing it with algebra just makes it more. You can be certain that it will be right for all cases. Okay, question 3. Function of x is equal to kx squared, where k is a constant. Kia says that the function of 6 divided by the function of 2 is equal to f of 3 because 6 divided by 2 is equal to 3. Is he correct? Show working to support your answer. Okay, so I'm going to do this. I've got to do really 2 stages for this. First of all, I've got to show what this would equal, and then secondly, I've got to show what this would equal. So let's start with the function of 6. So let's go f of 6, and I'll go straight to divided by f of 2. And that's going to be equal to f of 6 would be k times 6 squared. And f of 2 would be k times 2 squared, which would give me 36 divided by 4, which would give me 9k. Right, I also need to show, though, that f of 3 isn't equal to that. So, well, we can argue, yeah, so and I've messed up slightly here. K divided by k would be just 9, so that would just be 9. So f of 3 would be k times 3 squared, which would be equal to 9k. So they're not equal. Right, question 4. Work out the square root of 12 and a quarter as an improper fraction. So I'm going to convert this square root to an improper fraction first of all. So it's going to be the square root of 12 times by 4 is going to be 48, plus 1 would be 49 over 4. And then we can square root the top line and the bottom line. So that would just give us square root of 49 is 7 and the square root of 4 is 2. And we can argue... we could argue plus or minus. I'm just going to go 7 over 2. Yeah, I was in 2 minds about putting the square root in. If, for example, it said x squared is equal to, and then didn't have the square root there, we're finding x, it would be a plus or minus. But because we're actually saying it's a square root, we do assume the positive. Right, part B, work out the cube root of 16 as a power of 2. Right, well, I'm going to start by saying that cube root is the same as a power of a third. And then 16 is 2 to the power, well, we've got 2, 4, 8, 16. So it's 2 to the power 4. And then when we've got these, when we've got a bracket within our indices, we multiply the powers. So that's going to become 2 to the power 4 thirds. Okay, question 5. If you got the very first version of this paper, this question was actually written wrong. So when I downloaded it, I lost a 0 here. So this is kind of the second version. If you got that, just bear in mind that it should have been 0.07 reoccurring. So 0.7 reoccurring is equal to 7 over 9. Use this fact to show that. So 0.7 reoccurring divided by 10 would be equal to 0.07 reoccurring. And then a second sum, 7 over 9 divided by 10 would be equal to 7 over 90. And that's really all we need to show. Okay, using part A or otherwise convert a 0.27 to a fraction. Give your answer in its simplest form. Well, I'm gonna use this fact to help me out a little bit here, just to take a bit of a shortcut. And I'm going to say that 0.27 reoccurring is going to be equal to zero point 0.2 plus 0.07 reoccurring. So 0.2 is 2 over 10 plus, and we've already said that that is 7 over 90. Right. We can't add these fractions as they appear at the moment because we can only add them when they've got the same denominator. So I'm going to put the denominators to 90 for both, and I'm going to put them over the same denominator at the same stage. So to do that, I need to times this by 9, so that's going to become 18 plus 7, which is going to give us 25 over 90. And then I need to, it says in its simplest form, both these numbers can be divided by 5. So if I do that over here, if I divide by 5, that would give me 5 over 90 divided by 5 would be 18. So I'm looking at 5 over 18. Right, question 6. Here is a sketch of y is equal to sine x for the range of minus 360 to 360. Write down the coordinates of P. Well, if that's 360, P is obviously at 180, so that's going to be 0, 180. Done my coordinates wrong there. That should be 180, 0. Write down the coordinate of Q. Okay, so Q, the peak, so the sine graph or sine curve oscillates between 1 and -1. So my y coordinate is going to be -1. My x coordinate, I know that that would be minus 180, and I know that that would be minus 360, and I know that that's halfway in between, so that's going to be minus 270. And that was a 1, not a -1. So minus 271. Okay, question 7. The box plot represents the distance run by the players in a football match. So we've got team A and we've got team B. On average, which team's players ran furthest? So on average, the average that I'm going to refer to here is going to be the median, because that's what a box plot gives us. So we've got a median of, so team A's median was 9.8 kilometers, and we're just a flat distance, kilometers, and team B's median was 9.7. So which teams ran further? I would go team A, and the reason would be they have a higher median. A larger median. And then I'll quote the figures in my answer line: 9.8 kilometers, which is bigger than 9.7 kilometers. Part B, the players in Team A ran more consistent distance. How do the box plots show this? So more consistent means a lower interquartile range. We're going to assume that this is correct. Right. The interquartile range supports this. Then I'm going to quote them. So team A equals, and then team B equals. Right, so team A's is 9.9 minus 9.5. 9.9 minus 9.5, which would be 0.4 kilometers. Team, not really written that very well. Team B is equal to, checking my numbers there, 10.1 minus 9.6. 10.1 minus 9.6, which is 0.5 kilometers. Right, question 5. A geometric sequence starts 416. Work out the next term. So geometric means that there's a multiple between them. So we can see here we've times by 4. So our next term would also need to be times by 4. So we need to do 16 times by 4, which would give us 16, 32, 64. Right, part B. Fibonacci style sequence starts 3 and then minus 8. The sequence is continued by adding the previous two terms. Find out the next two terms. Okay, so the next term is going to be 3 plus minus 8, which would give us minus 5. And then the next term would be minus 8 plus minus 5, which would give us minus 13. So minus 5 and minus 13. Question 9. In a survey, queuing times in supermarket checkouts were recorded. One morning, samples of 50 customers were taken at supermarket A, B, C, and D. The box plot represents their results. Okay. On average, which supermarket had the lowest queuing time? So we're looking for the lowest median. So that would be supermarket C. So supermarket C, and the reason it has lowest. Right, today the lowest median. And then put in brackets 4 minutes. Part B, at which supermarket were the queuing times most consistent? Give a reason for your answer. So we want the one with the lowest interquartile range, which is going to be this one here. That would be supermarket B, and it has the lowest interquartile range, and we'll state that as well. 2 minutes. So the interquartile range means that 50% of the people that were asked or people that were measured fit in between the interquartile range. Question 10. Kim works at an airport in the UK. She records the number of planes landing between 10 a.m. and 2 p.m. each day. The table shows the data for the first 10 days in January. So 1 to 10, and we've got our values. The airport was affected by fog on one of these days. Which day do you think it was? Give a reason for your answer. So fog, you would assume that fog would mean that less planes were able to land. So we have got this one as an outlier. So it would be day 8. And it's because it's the lowest value or an outlier. So it doesn't match the rest of the data. So I'm going to say 102 is an outlier. And I'll put in brackets lower. Just put significantly lower. Significantly lower. Okay, part B. Kim uses the data to predict how many planes will land at the airport in a year. In her method, she uses an estimate of 150 planes in each 4-hour period throughout the day. Assume the same number of planes each day. Work out her prediction. So, okay, so first thing we need to do is 24 divided by 4. So that's how many lots of 150 we would expect. So we want to times that by 150, and then we want to times that by. So that's how many planes you would expect in a day, and then we want to times that by 365. Okay, so 24 divided by 4 is going to be 6. So I want to do 6 times by 150 times by 365. So 6 times by 150 is going to be 6 times 15 would be 30, 60, 90, so 900. So 900 times by 365. All right, so I'm going to, just to make that simpler for myself, I'm going to do 365 times by 9. And then I'll add 2 zeros on at the end. So 9 times by 5 is going to give me 45. 9 times by 6 is going to give me 54, plus the other 4 is going to be 58. 9 times by 3 would be 27, plus the 5 would be, 27 plus the 5 would be 32. So we would expect 3, 2, 8, 5, 1, 2. Yeah, I took 2 zeros out, so I put them back in. Alternatively, for that question, you could have, instead of times by 365, you could have times by 7, then times by 52, or you could have times by 7 to represent. I'm just double checking here. Yeah, so they're saying that you could also have times by 7, and then times by 4, which would give you 4 weeks in a month, and then times by 12, that would be fine as well. And any of those answers would get you a similar one. Other options, you could have had 324,000, 327,600, 329,400, or 333,000. They would all have been acceptable as well. Okay, part C. In fact, fewer planes land in the winter than in the summer. Fewer planes land at night than during the day. What does this tell you about Kim's prediction? Right, before we look at that, so she did hers in January instead of the summer, so that would mean that our estimate was an overestimate. Fewer planes land at night than during the day. We've done it during the day, so that would mean that ours is an overestimate. So because the first point means that our estimate, because the first point means that ours is an underestimate, and the second one means that ours would be an overestimate, the prediction could be too low or too high. So fewer planes in winter means an underestimate. Fewer planes got planes right in both of them, shall we? Planes at night means overestimate. So prediction could be too high, too low or high. Because we're not given any numbers, just a few there means that the first condition means that our estimate could be an underestimate. The second one means that our prediction could be an overestimate, and we don't know how many fewer, so her prediction could be too high or too low or too high. Okay, question 11. P and Q are points. P is at -3, -2, is mapped to Q by a rotation of about the point 10 through 90 degrees clockwise. Q is then mapped back to P by a single transformation. Complete these two transformations that each map Q back to P. So we could have a rotation or a translation, that's right. So if we think about where it would go to, first of all, first of all, we'll say it could be a rotation about 1, 0, and let's through 90 degrees. 90 degrees anti-clockwise. I'm going to put a second version in underneath. We could say that it's through 270 degrees clockwise. That would also hold true. Right, for the second part, translation of. So let's think about where Q would actually go. So currently it is 2 below and 2, 4, 2, 4 to the right. So it's going to go 2 to the left and 4 up. So that would be point Q. Just double checking I've done that in the right direction. That looks right. So we could do a translation of, and then we can just state the vector. So we're going to have to go, top number is always left or right. In this case, we've got to go 2 to the left, which would be a -2. And then we've got to go 2, 4, 6 down, which does make sense. So -6. Okay, question 12. Point A, which is at 7, 4, and the line y is equal to x is shown on the grid. B and C are points on the grid, each having positive integer coordinates. Okay, BAC is a right angled triangle. When ABC is reflected in the y-axis side, BC is an invariant, so B and C must be on that line. Work out one possible sets of coordinates for B and C. Okay, I will go for the very most obvious first of all. So we could have B and C there. It doesn't really matter which way around. So that's going to be 4, 4, and 7, 7. And we could have had those the other way around. Right. That's not the only possibility though, so I'm going to do the second one here. And this will take me, I might mess this up, but we'll give it a go. So if we imagine that one of the points was there, so that if we're creating a right angle, we would need, that would create a right angle as well. So we could have had 1, 1, 6, 6. That would have been a possibility as well. That would be much of a less common answer though, but that would be allowed. Okay, question 13. Here are sketches of two graphs. So we've got y is equal to x squared minus 1, and then we've got graph A. The graph of y is equal to x squared minus 1 is translated 3 units to the left, give the graph of A. The equation of graph A can be written in the form y is equal to x squared plus bx plus c. Work out the values of b and c. Okay, so if we refer to it like this, if it's been moved 3 to the left, in effect, that's y plus 1, y plus 3. So, don't particularly like how this is written to explain it. If I switch this and say that the function of x is equal to x squared minus 1, if that graph is shifted 3 to the left, that becomes the function of x plus 3. That's going to be x plus 3 squared minus 1. So that would give you x squared plus 6x plus 9 minus 1. So tidy that up a bit, that gives us x squared plus 6x plus 8. So b would be 6 and x would be 8. Right, part B. The graph of y is equal to x squared minus 1 is reflected in the x-axis to give graph B. Work out the equation of graph B. Okay, so again, if I call this a function of x is equal to x squared minus 1, we're doing minus f of x. So it would become minus what x squared minus 1. So that would become minus, if I give the equation, so y would be equal to minus x squared plus 1. Okay, question 14. Joe wants to work out the solution of x squared plus 3x minus 5 is equal to 0. She says the solution cannot be worked out because x squared plus 3x minus 5 does not factorize to x plus a times x plus b, where a and b are integers. Is Joe correct? No. This just means it can't have integer solutions. Yeah, I'll say this means that the solutions are not integers. She could solve by completing the square or using the quadratic formula. Okay, with that, expanding any brackets, show how to work out the exact solution of this, give your solutions. Okay, so we will start with saying by not expanding the brackets. So the first thing I'm going to do is divide both sides by 9. So that will give me x plus 3 is equal to 4 over 9. I'm then going to square root both brackets. So that will give me x plus 3 is equal to plus or minus the square root of 4 over 9. So x is going to be equal to minus 3 plus or minus the square root of, and I don't need to do that. Square root of 4 is 2, and the square root of 9 is 3. Give the solutions, so we could have had x is equal to, let's do minus 3 minus 2/3, so that would be minus 3 and 2/3. Minus 3 plus 2/3 this time would give me minus 2 and 1/3. So those are going to be my exact solutions. Okay, question 15. Here is a velocity time graph of a motorbike for 25 seconds. How many seconds was the acceleration? After how many seconds was the acceleration 0? So for a velocity time graph, it's the gradient that gives us the acceleration. So the acceleration is 0 when we have, it's going to be there. So we're looking at finding this value here. So if we're going up in twos, it looks like, so I'm going to go 6.5. Do I agree with that? So I think it's just over 6. Do I think it's 6.5? 6.5 would actually be slap bang there, so I think it's halfway between 6 and 6.5. So I'm going to go 6.25. What? Right, let me just have a look. Okay, so anything between 6 and 6.5 is acceptable. Right, work out the distance travelled in the last 15 seconds. So the last 15 seconds, no. So the last point is 25. So 15 from there would be this point here. So that looks pretty much like a trapezium. So I'm going to treat it like a trapezium. The distance is going to be the area. So the area is going to be equal to a half of, and we want to do this value, or if we call this A, this B, and this the distance here, H. So it's going to be half of A plus B times by H. So that's going to be a half of A is looking like 22. B is looking like 15, 16, 17, 18. And then we want to times that by 15. Right, so we're after a half of 40 times by 15. So that's 20 times by 15, which is going to give us 300. So 300 meters. Question 16. This diagram shows a triangle and a trapezium. Okay, prove that A is equal to B. Okay, so we're going to start by saying that C is going to be equal to, if I'm looking here, we've got co-interior angles. C is going to be equal to 180 minus B. And then we're going to say angles around a point. So 360 is going to be equal to A plus 65 plus 115 plus C. Right, now I'm going to tidy this up a bit. 360 is going to be equal to A plus, these two would add together to make 180 plus, and then instead of C, I'm going to write 180 minus B. So this tidies up to say then that, so what I've done is substitute that in for C there. So 360 is going to be equal to A plus 360 minus B. So 0 is going to be equal to A minus B. So A must be equal to B. Okay, question 17. Which of these is a geometric progression? So we need a constant multiplier between them. So let's say times by 2 times by 1.5. So I can get rid of that one. This one has a difference of 1, difference of 2, difference of 3, difference of 4. So that's not a geometric. This one has a times by 3, times by 3, times by 3. So that one definitely is. And then this one definitely isn't. So just that one. Right, question 18. A and B are two events. Some probabilities are shown in the Venn diagram. So we're missing this one here at the moment. All of them need to add up to 1, but we might not need to work that out. Work out the probability of the union of the complement of A plus B. Okay, so if we look at, I'm going to shade these in just to help me out. The complement of A is everything that's not in A. And then I'll change pen color for this. B is anything that's in B. So if we want the union of them, that's everything that's shaded in. So that's everything bar the 0.3. So that's going to be equal to 1 minus 0.3, which is going to give you 0.7. 0.7. Okay, question 19. Here is a sketch of y is equal to cos x for the values of x from 0 to 360. So starting at 1, and the pattern repeats itself every 360. Is that an A or an alpha? Either way, we'll call it A. A is an acute angle. Cos of A is equal to x. Okay. Circle the value of cos of 180 minus A. So 180 minus A is going to be, if we kind of imagine it, so A is that distance there. At 180 we're here, so I'll call that minus A. So that would give us minus K. Circle the value of 360 plus alpha. Sorry, 360 plus A. So 360 brings us to here. And then if we plus A again, so if we imagine this carrying on, and then plus A again, it would give us the same point. It's okay. Question 20. B is 2/3 of C. 5A is equal to 4C. Work out the ratio of A to B to C, giving your answer in its simplest form, where A and B and C are integers. Okay, converting equations into ratios. So I have, well, I always do it the same way. And B is 2/3 of C. We can write that as B is equal to 2/3 of C. Right, so if I rearrange this to just have the letters over each other, so I'm going to rearrange it to be A over C is equal to 4 over 5. And then if I do the same over here, I can say that B over C, B over C is equal to 2 over 3. Right. That means that if A over C is equal to 4 over 5, then the ratio of A to C is 4 to 5. And then here, if B over C is equal to 2/3, then we can say that the ratio is 2 to 3. Right, if we want to combine them then, so I'll do that over here, A to B to C. I'm going to put those ratios in that I know. So A to C is 4 to 5. And then from the second one, we've got B to C, 2 to 3. So our point where we can combine them then is our C. We can make them equivalent ratios of 15 to combine them. So the first one needs to be times by 3, so that would give us 12. And the second one would need to be times by 5, so that would give us 10. So we're looking at 12 to 10 to 15. Right, question 21. This Venn diagram shows information about houses. G is houses with garages, and S is houses with sheds. A house is chosen at random. The house has a garage. What is the probability that it has a shed? A house is chosen at random. The house has a garage. What is the probability that it has a shed? So, not over the moon about the wording of this question. So I feel that my issue here is picking the denominator. If it tells us here a house is chosen at random, that should mean that the denominator is out of the total number. Are we told that total number? We're not. So let's do it over here. So the denominator should be 13 plus 8 plus 11 plus 4. And then what? The house has a garage. What is the probability that it has a shed? So if it's got a garage and a shed, that's going to be 8. So we're looking at 8 out of that number. Then if we add that, that's going to be 21, 32, 36. So that should be 8 out. So we're definitely out of 8. I'm struggling with the wording of the question. A house is chosen at random. That normally tells you what the denominator is. But then here we've got the specifics for this question. The house has a garage. So that argument arguably says that that's just going to be out of those two. The house has a garage. What is the probability that it has a shed? So I'm going to go 8 out of 21. Let's see what the question says. Let's have a look. No, they've gone for 21. So yeah, I don't know the word another question, but they've gone for 8 out of 21. Part B, the house does not have a garage. So I'm going to assume that that's going to tell us the denominator as well. Does not have a garage, so that's out of 15. 15 houses do not have a garage. What's the probability that it does not have a shed? So I'm going to go 4 out of 15 for that one. Right, part C, show that the probability of GNS complemented, so that's the probability that it's not in the intersection, is greater than the probability of G union shed complement. So I'm going to start with PGNS complement. Right. So I'm going to work out the probability that it is in the union, the intersection of that first of all. So that's going to actually be 1 minus 8 out of the total number, which is 8 plus, and this brings the whole 13 plus 8 is 21, 32, 36. So that's going to be 28 out of 36. Right, now I'm going to look at the probability of GUS, and the complement is just on the S. Okay, so that's going to be out of 36 again. Right, the union of, so that's going to be these three. And again, if we wanted to look at it in terms of shading, so the probability of G or G is going to be these. And then the complement of S is going to be these. So again, I'm going to do it as a 1 minus. So it's going to be 11. So let me just, so it's going to be 1 minus 11 over 36, which is going to be equal to 25 over 36. So that's the two probabilities. And 28 out of 36 is bigger than 25 out of 36. Okay, question 22. X kilometers per hour is equal to Y miles per hour. Use 8 kilometers per hour is equal to 8 miles per hour to write a formula for Y in terms of X. Okay, so this means then that we would need 5 lots of X would be equal to 8 lots of Y. Because if we're saying that 8 kilometers is roughly equal to 5 miles per hour, we can say that that's going to be 5 lots of X will be equal to 8 lots of Y. Because whatever value you think about, that would work. So we want a formula for Y in terms of X. So that's going to be Y is equal to 5X over 8. So Y is equal to 5X over 8. Right, 23, solve minus 3X is greater than 6. Right. The issue with this, it looks really simple, but it's not quite the same as just dividing by -3. The easiest way is I always say, whenever we're solving inequalities, it is a nightmare, or not a nightmare. You just need to remember that whenever you divide by a negative number, you need to switch the inequality symbol. The easiest way to kind of explain this is to say, I don't want to divide by a negative number. So if I kind of add 3x and -6 from both sides here, I would get that 6 minus 6 is greater than 3x. Then if I divide both sides by 3, I would get -2 is greater than x. So my inequality is x to be less than -2. So I've just had a mini glitch. I'm not sure where that writing's gone. So again, let me just do that quickly. So if I move these to the other side, I would get -6 is greater than -3x. Not -3x, greater than 3x. If I divide both sides by 3, I get -2 is greater than x. So that means that x has to be less than -2. You can divide by -3 for your first step, provided you remember that you need to flip your inequality symbol over. Right, question 24. ABCD is a trapezium. All four sides are different lengths, so are different lengths. We're told that AB is parallel to CD, and the diagonals intersect at X. Okay, for each statement, tick the correct box. So triangle AXB, so let's do AXB. And CXD, CXD. Are similar, so that one would be true because that angle and that angle and that angle and that angle are alternate, so that would be true. AXD, so let's change colour for this. AXD, AXD, that one there, and BXD, BXD are congruent. That one is not true because we haven't got any corresponding angles. Yeah, so that one's not true. Angle ADB, so we're in our colours now. ADB, ADB, so that angle there is equal to BDC, BDC. So that one is definitely not true. Could it be true? It could only be true if we've got equal sides, so that one's definitely not true. Right, the final one. Look at the colours I haven't used. The area of ABC, so ABC, ABC, so the area of that one is equal to the area of ABD, ABD, so is equal to that one. Right, so we can, yes, that one would be true. Reason being, we've got same side here, so the area of a triangle is equal to half of the base times by the vertical height. So that's a key factor here. So if that's the base for both of them, they've both got the same base. And then they would actually both have the same vertical height because it needs to cross at 90 degrees. So that would be the height for both. So that one would be true. So for that one, I'm going true, not true, not true, true. Okay, question 25. ABC are points on a circle. CD is the tangent. Assuming that triangle ABC is an isosceles with angle with AC being equal to BC. So AC, don't like that colour very much to write with. So we're saying that that angle and So that side and that side are true. Prove that AB is parallel to CD. Okay, so let's start by saying that that angle there would be X and that angle there would be X. So, call it BAC is equal to ABC. Proof would be base angles of an isosceles triangle. Right, and then we can actually say that that angle there must be equal to X. So we can say that, and I'll do it as ACD must be equal to, and it's this one that it should be equal to by the rule that I'm about to use, is equal to ABC. And that is the alternate segment theorem. And then you can kind of work backwards from this. So you can actually state that so BAC must be equal to a CD. So AB must be equal to, must be parallel to the parallel to DC as these angles BAC and ACD are equal, so alternate angles. Okay, part B. In fact, the triangle is an equilateral triangle. Tick two of the statements that must be true. So AB is parallel to CD. AB has still got to be parallel to CD, so that would be true. AC bisects AC, O to C, bisects the angle BCD, BCD. Well, yeah, that would be true because all those angles are going to be 60 degrees. So that one would be true as well. AC bisects the angle BAD. AC BAD. No, that one wouldn't be true. So it's just those two. Okay, question 26. Three whole numbers are each rounded to the nearest 10. The sum of the rounded numbers is 70. Work out the maximum possible sum of the original three numbers. Right, so for this, let's think about it. So we've got three numbers. Let's call them A, B, and C for now. So if we imagine they equal 70, the maximum that they could possibly be, because if we think there were whole numbers originally, so actually this one could have been two bigger, three bigger would have been rounded upwards. This one could be two bigger as well. Oh, just realised it's to the nearest 10. So if it's to the nearest 10, it's not 2. I've gone to the nearest 5. If it's to the nearest 10, it could have been 4 bigger, because 5 would have been rounded up. So B could have been 4 bigger, C could have been 4 bigger, which means that this could be 12 bigger. So we're going to go 82. Okay, circle the expression for the range of n consecutive integers. Okay, so this this sounds complicated. If we imagine the first one would be a, and then all of the others would have been a plus the other number. So if we imagine that that was the first term, and then that's the nth. Actually, the first term would be a, but the last term would actually be a plus n minus 1. Because if you think about this, this would be a plus 1, which would be the second term. So if we're trying to do it with algebra, we'd be doing a plus n minus 1 minus a. The a's would cancel, so that would give us n minus 1. Could have, of course, viewed it as just normal numbers. So if we call this one the first one 1, and then the last one n, then it would just be n minus 1. Yeah, definitely. Okay, question 28. A bag contains 8 balls. 3 are red, 5 are blue. 2 balls are taken from the bag at random without replacement. Write down the probability that at least one of the red balls, is still in the bag. Well, if there are 3 red balls to start with, 2 balls are taken from the bag without replacement. Write down the probability that there are at least 1 red ball left in the bag. There has to be 1 left in the bag. Because if there are 3 originally and 2 are taken, there must be 1 left. Even if you took both red, so that's going to be 100% or 1. Part B, work out the probability that at least 2 red balls are still in the bag. So lost my work there. So let's do that one again. So we've got 15 machines working 8 hours. So 15 times by 8 will give us the total number of working hours. So that's going to give me a total of 120 working hours. All machines work fine for the first 6 hours. So 6 times by 15 would give us 90 working hours done, which means we've got 120 minus 90 would give us 30 working hours left to be completed. And now, because of the 3 machines that have broken down, that's going to be split between the ones that are left. So 15 minus 3. So that's going to be 30 divided by 12. They both cancel down by 6. So that's going to be 5 over 2. So that they need to work an additional 2.5 hours extra. So that's the full 6 hours plus the additional 2.5 gives you a total of 8.5 hours. So the remaining 12 machines will need to work a total of 8.5 hours. And that brings us to the end of the paper. Before I sign off, I'm just going to bring up the Q&A. Okay, so this is the advanced Q&A for this paper. You can kind of see how it was built up. So the 29 questions. The paper was actually out of 82 marks, so I picked the 82 most So what I did was I looked at the question facilitated by grade and I picked the hardest ones based on previous students having sat it, and then I arranged it by questions facilitated by grade. The ones that are in Peach, they're only in Peach because they're partial questions. For example, the probability and set notation was like a 3-part question, and I've just arranged it by the hardest aspect, which is why the total here doesn't actually add up to 82, because each of these marks, the ones in Peach were actually worth more than those marks. The chapter index for this video will be linked to the topics. So if you found one of the questions particularly challenging, or you just want to skip through to certain questions, feel free to do that. If you did struggle with one of those questions, that's where I'd recommend some additional revision ahead of your exams. Other than that, thank you very much for joining me for this. I hope you found it useful. If you have found it useful, please do subscribe and you will get automatic pings as soon as I release any new videos. If not already, please do check out my predicted papers, predicted topic papers, I should say. I've done a AQA and EdXL ones now. They're on my site. Feel free to have a look at those as well. As always, please let me know any comments, questions, or feedback in the chat to the video, and I'll get back to you fairly quickly. Other than that, I hope your revision continues to go well, and good luck with your upcoming exams, and I will see you soon.